Yes, I had to step in for my sick colleague, so you have to be nice to me, I think, because I don't know. He forgot to tell me what to talk about. He said you can have a presentation of tile. Okay, I can do that. Over 1 year since I work with tile in the Equinor Spine project, and tile doesn't look like it was 4 year ago. So, but I will try to give you a demo of tile. First of all, I want to thank you all for a lot of great presentation. It has been nice to hear what you're doing, all of you, and it's a lot of great work done. I know, because I'm a developer myself. I will give a special thank to Webstep. A star from me today, because I think the most one important thing from this day is to start thinking different. And this is tile all about, is how to do things in different ways. So this is not a presentation of an application that is similar to other things we have seen today, but it's a tool to create EMF types in a semantic way, and I want to demonstrate that for you today. So tile is a type editor for EMF types, hopefully a common application for the entire industry. We hope so. It's an open source product. And I think, like Webstep said earlier, I think we have, and many other, I think we have to think in another way, and we have to cooperate on common solutions. So, what we think about the architecture? Tile is a client application. This is a little bit technical. It's a React app, and the tile server is a .NET application. We have a backend SQL database, and tile is integrated with PostCSI, with the class library. And tile is producing EMF, valid EMF types. I will give you a demo of that afterwards. So this is all about creating types. So let's go to the demo. Log in. And here you can see a front page with a lot of types. We have attributes. We have what we call blocks. Yeah. So it's a list of IMF types. Terminals and so on. We have, you can create the different types. So let's start to create an attribute. Give it a name. See what we call this. I'll just call it demo for this purpose. And it's hard to. And you see I have different predicates. Predicates coming from PCA. So let's see, it's electrical introduction and some descriptions. And you can choose qualifiers. That's what we call qualities. Calculated qualifier, measure qualifier, specify qualifier. So let's do some of this. It doesn't make sense because this is my, I have no clue about what is the correct data here. So, and you can add units, and units here is connected to PCA as it is today. So this is, I want doesn't make sense, but yes, add units. You can see something about this is optional, this is required, and so on. And you can add value constraints. It means that he has a specific value, a list of allowed values, and so on. So it could be predefined values in the attribute. Let's turn it off for now. And this is going to create a new type. So let's see. Let's call it demo attribute. So it's a method. We have a demo attribute, and you can watch it, I think. You can edit. And you can, Tile has also a workflow for approval. So this is in the draft state. You have to approve, and you can give different access to how do the approve state. Okay, so let's create a terminal. It's gas terminal. Doesn't make sense, but okay. Notification, I'm not sure. You know, Magnus? You have you that have been working with the new EMF and so on, you know about the aspects and so on. So this is the function, product, and location, and installed aspect. Let's see it as a function aspect and give it a purpose. And this description. Yeah, the same way, a terminal type could be qualifier, input, output, and it has a medium. I'm not sure about this one. And you can add classifiers. And also terminals has attributes, so we can collect the attributes we created. So let's create a type. Another thing is that if you go back to the demo attribute, I'm not going to clone it. I'm going to edit it. And copy. If you go to the attribute endpoint, so take this ID. And there is created. And that is a valid EMF. It's a shackle, a JSON ADF file for this attribute. Could be imported in processor as a type. And we have the same endpoints for terminals and for blocks. So let's create the last one I want to demo today. It's a block, and let's call it demo block.
Go ahead, Reidar.
Yeah.
You can create a pump, for example.
Yeah.
So I can tell a bit about, this is an example of a tool that can smooth out the process of creating a library and onboard our engineers, right? So it's meant for the engineers to be a user-friendly tool to propose new content to the library, to speed up that process. So go away from Excel sheets and so on. And now Reidar as well has shown a bit about the format that we have been working on the background here that can be validated. So we can validate, is this according to the standard? Is it okay? And yeah. But yeah, go ahead.
Yes. Notation for pump, Magnus?
RDS notation? Is that? You can skip that. It's not important.
Skip it. Let's make it for the function aspect. Purpose, pumping. Makes sense. This is a pump. Classifiers. I couldn't see any classifiers in, maybe in that database is empty of classifiers. But we could add attributes. So let's add some. Flow. So
yeah, so these are attributes and class definitions that you should find in the POSC CSAL library, right? So you are connected to a common library. You pick out the pieces and elements and put them together that makes sense for an engineer. For example, a pumping object or an IMF types that we call it.
So have these attributes. You have also minimum and max value to start. You could add some terminals. Do you have some terminals for this? Fluid? Something?
Yeah, you would probably have some fluid in, some fluid out, and a power connected to it.
Oh, where's my mouse? Something power. Electrical power. More?
That's shows the principle.
And we can add some symbol. I talked as WebStep demonstrated earlier. This symbol is fetched from the symbol library. So you can see here that this pump has connectors, as WebStep talked about. Same data, talking the same thing. And here we can use this one, and we can say that this is the electrical power input, and this is the fluid flash input. And we could create this type. Here we have the pump. Let's copy this pump. And here is the correct EMF object. So that's what I want to demo from Tile today. So
thank you so much. Big applause to Bouvet. And I have to say that I think it's exemplary how you speak positively about actually a competitor here at this scene. That is something we would like to have in our environment, right? Because it's all about collaboration. So that was very good. Thank you.
This is open source, and you can find it on the GitHub, Reidar.
yes,
You say something about that?
It's placed on there. I can say something about that. I can do that. 2 seconds. There's the mouse. There. It's placed there. Hard to. Yes. Of course. Sign-ins as I come from. Makes sense. Mimi, this is the community, and here is the source code for Tile. And it's open source. And both backend and the front-end the code is placed there. So it's free to use it. And yes, I can see at the same time we have another application I call Mimir. Mimir is about when we are connecting these types. It's a drawing phase to draw in the all aspects of data and connect relations between them about the part of relations we know about from the IMF and connected to or has function, or has location and so on. So it's a drawing tool, drag and drop with types from tile to draw it. But we don't have, because of a major refactoring at the moment, so we don't have a demo on Mimir today. But source from this is also here.
Thank you. I think this was a really excellent presentation of a user-friendly tool. So I think engineers will love to use it and understand how we're going to propose IMF types based on the PCA's library. So I think it was an excellent demonstration.
Very good.